Okay, so this is your first question. Start to solving this question and comment your answer in the comment box. Okay, put your answers in the comment box or chat box. Neelam Alun, start solving the question. I'm giving to you all only 30 seconds for this question. After that, I will explain you and we will solve all the question. Okay. Both of you just try. If you are able to solve, that's great. If you are not able, there is no issue at all. I will explain you. $30. I will start after 30 seconds so that you guys also able to solve. Okay. Take 2. Okay, Neelam. Let's see. Arun, what about you? You are able or not? Okay, no issue at all. So what the question is saying, first read the question carefully. The minimum number of stacks needed to implement a queue. So here what we can say, if we have to implement a queue, then we have need 2 stacks, or what we can say, the minimum number of stack required is 2. It is direct question. Okay. So read the question. The minimum number of stacks needed to implement a queue. Okay, so there is 2 stacks required to implement a queue. Okay. Next question. This is, as you know, this is our Telegram group. You have to just scan this QR code and join the group. You will take all the update and a link regarding the live class, and if you want to get PDF notes also, you have to join this group so you can get everything from here. Okay. Okay, next question. This question we will do later on. First, okay, this is from programming in C. So you have to try to solve this question. I hope so you all will able to solve it. It is very easy question. So just try, and after that I will explain you. Again, I am giving you 45 seconds to solve this question. 45 minutes are sufficient to solve this question. Okay, so just try. 𝗙𝗵𝗵𝗹. Neelam, are you able to solve, or I have to start? Okay, now see, I'm going to start, and you guys have to see the question very carefully. Okay, so in this question, what is given? First, see this. Consider the following C function. Okay, as include it is header file, as you all know. I hope so you all know that. Okay, int man. Okay, here given a character array. Okay, this is our character array. Okay, what is given? I, C, R, B, C, S, I, T, 1, 7, and at the end there is a null character which is \/ and 0. Okay, indexing always start from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this is 10, last null character. Okay, so now what we have to do, see there is one another pointer which is p, and what we are doing over here, we are just giving the address of C to the another pointer which is P. So what will happen after this statement? There is another pointer P. It will also point this atlas. Okay. Now what is happening here? See, in this step, printf. Okay, percentage S C. See, what is C? It is pointing to a character array, or we can say base address of the character array. Base address over here plus. This is plus 2p. 2p. What is mean? What is this mean? Okay, p pointing this character array, and this is second position, or we are talking about second position's element. Okay, not atlas. We are talking about element of second position or second index. Okay, not there is, I'm not talking about second position. Otherwise you will say, so this is first position, this is second position. No, I'm not talking about it. I'm talking about index number second, which is 2. Okay, and I am talking about the element of index second, which is R. Okay, I think you guys are got it what I am trying to say. Okay, so here what you can do, you can write simply over here R. Okay, that's it. You don't have to do anything. Okay, just write a character. Okay, now what we have to do? P6. We have to write the element of position 6. Okay, position 6, I mean to say index number 6. Okay, at index number 6 there is a element present which is I. So just minus, this is minus symbol. Okay, so what we are doing, we are simply writing minus. Then what we have to do, we have to simply write I. Okay, or then minus 1. Okay, this is what we have already done. Okay, this is we have done. Okay, now this is base address plus order of R. What we can say, if we are saying that A is 1, then R is 18. Simply we can say, what is the order of R? It is 18. If we talk about ASCII code of capital A, it is 65. And if we talk about ASCII code of R, then kindly add 17 in 65, because you can got it what I'm saying. 0 to 17, it's 17 minus 0 plus 1, it is 18. Okay, so that's why I'm adding 17 in 65. Okay, got it. So I totally understand. Otherwise you can simply put here 18, here I. What is I? 9 minus 1, which is 10. 10 plus 18 minus 10 plus 18, which is 8. So base address plus 8. Okay, now what we have to do? We have to reach at this position and start planting till we get null character. Okay, so here 0, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. We have to start planting from here. 7, 1, 7, and now what we are getting? We are getting null character. So we have to stop our planting. So what we are getting in the answer? 17. This is our final answer. Also, you guys all got it. What understood? Neelam, Mukesh, 𝗙𝗵𝗵𝗹. If you have any kind of doubt, you can simply ask. There is no issue at all. Okay, Neelam, very good. 𝗙𝗵𝗵𝗹, what about you? What about you? Okay, good. Or Mukesh? Okay. Now we are moving on next question. Just focus. Okay. This is from OS. this is such a very good question. Try to solve it. It will take you all 50 seconds only. You have to answer of this question only 15 seconds. 15 seconds. I am expecting answer from Neelam and 𝗙𝗵𝗵𝗹. Just try to answer it as fast as possible. Okay, Mukesh, very good ladke. Try to answer it. It is very easy question. Betting. You guys can interact. You guys can unmute yourself and you can interact. There is no issue at all. If you will ask or if you will speak, then I will explain you in more detail. I will feel also able to solve or not. At least put in the chat box. Mukesh, fork is a system call. Yeah, Mukesh, you are right. Fork is a system call. Right. It is a topic of operating system. It is quite important topic. Almost every year 1 and 2 question comes from this topic in every technical examination. If we talk about which is from field of computer science, you will always see 1 or 2 question from fork system call. Okay, Mukesh, no issue at all, no issue, ladke. But from today onwards, you are not going to be forget this formula again. You will always able to recall whenever you want. So just okay, fine. Now I'm solving this question. Now focus here. Okay. Okay. So first, what I'm doing, I'm just leading the question carefully. A process executes the following segment of code. This is the segment of code which is one process is executing. This is what the question is saying. Okay. Now what is question is asking? The number of new processes created is the number of new processes. Okay. This is what the question is asking from us. Okay. Now what we have to do? Simply just put n barabar 3. Just put. Okay. So what will happen? See here. For I equal to 1, I less than equal to n, and I plus plus. Okay. Then what we have to do? We have to put 3 in place of n. Do it. I equal to 1. I less than equal to 3 and I plus plus. Okay. Then fork. We are calling fork. Okay. This is what we are doing. Okay. Now execute it. I equal to 1. 1 is less than or equal to 3. 3 is greater than or equal to 1. Obviously, this is true. So what will happen? The execution of this code will enter into the body of the loop. Okay. Here what will happen? This function will create a child process. Okay. Okay. Fork system. Simply what I'm saying. Listen it. What actually fork function do? It create a child process. Okay. Okay, got it. Okay, fine. Now okay, 1 is less than or equal to 3, right? A fork system call, or what we can say, fork will execute at 1, at 2. Also this condition is true. Again fork will execute 3 less than equal to 3. Again fork will execute. Okay, that means this this fork function will execute 3 times for this condition n equal to 3. Okay, so how many new process will created? Only what actually fork system call do? It's create a child process. Okay, see that. if we are calling at 1, what it will do, there is a parent process, it will create again a child process, there is two process. Okay, again what it will do, it will create again a child process. So parent process remains and one more child process will create. So actually what will happen, this is our main process. Okay, apart from it there are 5 processes which will created and which will new processes. Okay, so same will happen here. If we are running this loop for n times. Okay, so see that if we are putting n equal to 3 over here, what will we will get? 2 power of 3 minus 1. What will happen? 2 power of 3, which is 8 minus 1. Actually, we are getting 7. 4, 8. Okay, minus 1. Okay, why we are subtracting 1? It is our main process. And how many new process will created? It is 7. Okay, so 7 new process will created if we put n barabar 3. With similar error, if you will trace this code after putting n equal to 3, you will find there is 8 total number of process will be 8, and apart total number of process will be 8, and in total process there are 7 process will that process which created newly. Okay, so similar with a similar error, what you have to do, you have to just you have to learn this loop till n times. Okay, so what will happen here, new only we are talking about new process, so 2 power of n. Okay, similar with it. See this example, what we have did here, we just put it in place of n 3, which is 2 power of 3 minus 1, we have subtracted just because this is our main process and we want only newly process. Okay, so that's why we are subtracting this one. So similar here, if here in place of 3 there is n, so we have to simply put 2 power of n at place of 3, we are putting now n, and we are only subtracting 1 just because this is our main process or parent process, and after subtracting 1 we will get only new process which will created after executing this segment of code. Okay, so what will be the answer of this question? 2 power of n minus 1. This is simply the answer of this question. Okay, now I am giving you some points. Write it or understand. Try to keep this point in your mind. Okay, if someone will ask you total number of child process, total number of child process. Okay, then what you have to do? Simply 2 power of n minus 1. Okay, what is n here? The number of times your Fox system will execute. Okay, if someone will ask you total number of processes, then what you have to do? Simply 2 power of n. 2 power of n, your total number of process in Fox system call, and 2 power of n minus 1, total number of child process in Fox system call. There are two formulas which you have to remember. Okay, first total number of child process, or second total number of process, and what you can say here, total number of newly created process. For that also you will use this same formula. Okay, got it or not? If you guys have any kind of doubt, you can ask. Unmute and ask. Okay, Mukesh, good. What about you, Neelam and ऋषिकेश? You are able to understand or not? 𝗙𝗵𝗍, what about you, ladke? Kindly acknowledge me so that I can understand you guys are getting or not. Okay, Neelam, good. Okay, so we are moving on next question. Okay, this one again from C programming and a very interesting question. Option C is the answer. 𝗙𝗵𝗍. Option C. Okay, let me see. Okay, good 𝗙𝗵𝗍. Nice ladke. Option C is a correct answer of this question. Okay, बहुत अच्छे. Okay, now solve this one. Solve this one. The following C program is executed on a Unix or Linux system. This is your header file and this is your main code. Now the total number of child process created is. Simply you have to check how many times this fork will execute. Then after checking it, just put your your what we can say the number of times fork will execute in this formula to power of n minus 1 because he is asking about child process. Okay, so just check how many times will your fork system call will execute and the number of times put in place of n. You will get your answer. Just do it now. B. Mukesh, 31. Okay, ladke. Wait. Whenever I will solve it, you can verify your answer. What about Neelam?
Sir, I'm solving. 2 minutes.
What?
Sir, I'm solving. 2 minutes. I need 2 minutes.
Okay. Try. Solve. Take your time. No issue at all. But at least you guys have to interact with me. If you will interact, then I will put more efforts. I will enjoy teaching whenever you will start interacting with me. This is made and you have chance to interact with your teacher and you can discuss all your doubts. And now we are doing only basic question. I have a very interesting question in this class, in this PDF. After solving these 2 and 3 question, you will find more interesting question. And
Sir,
whenever you
I'm
will
getting
solve,
31.
okay, Neelam, fine.
Hello.
Okay, now I'm solving. Verify your answers. Okay, Neelam and Mukesh are saying 31. Okay, Neelam and Mukesh 31. Let's see and verify your answer. Okay. So what is happening over here? Let's see. Int I, there is a variable I and it is declared as integer. Okay, now in for loop, what actually is happening? What is happening over here? Okay, here I is initialized with 0 and what we are doing, we are only checking this condition I is less than 10. Okay, so 0 less than 10, true, a loop will execute it. Okay, we are reaching over here. If I modulo 2 equal to 0, then fork will execute, otherwise not. 2, what will come? 0. For this, fork will execute. Fork executing here only first time. Okay, first time fork is executing. Now what will happen? I will increased by 1. Okay, 0 plus 1 equal to 1. Now 1 is less than 10. Yeah, condition is true. We will enter into the loop. Now what we are checking? 1 modulo 2 equal to 0. No, it is 1 equal to 1, which is false. So fork will not execute for I equal to 1. Fork will not execute it. Okay, now what we have to do? Just I will again increased by 1. So what will happen? I plus 1 equal to 2. Okay, this is what will happen after this, after condition check. Okay, so see over there, see. So I equal to 0, fork executed. I equal to 1, fork not executed. I equal to 2. See, I equal to 2. Okay, 2 less than 10. True or false? It is true. We will enter into the loop. Okay. Now 2 modulo 2 equal to 0. Is it true or false? Is it true? So okay, fork will execute again. Okay, 2 times. Okay, now see what will happen. 2 plus 1 increased by 1. Again, this is what actually happening in ablaze tab. Okay, so 3 less than 10. Obviously 3 modulo 2, it gets 0. Not, fork will not executed. Fine. Okay, not executed. Again, it will increased by 1. It will be 3 plus 1 will be 4. Okay, just because of I plus plus increment. Okay, so what will happen? I 10, it is true. 4 modulo 2 equal to 0. It is true. So I equal to 4. Fork will again executed. Okay, that's true. Okay, so I am getting what you are saying. Okay, now see again, see again 5, 6. Now you got it what I am doing over here. Okay, see. Okay, 5 modulo 2 equal to 0. Not, fork not executed. 6 equal to 2. Again 0. It is true. Fork executed. Not, again not. This is condition is false. Sir. We will not enter into the loop at 10 less than 10. Okay. So how many time your fork will execute it? See. For this not, for this will, for this not, for this will execute it. This not. Okay, so 1 time, 2 time, 3 time, 4 time, 5 time. Your fork system will execute it 5 times. So now what we have to do? We have to find number of child process. So what we will do? We will simply 2 power of n minus 1 formula. We will put the value at place of n, the number of time fork will execute. Okay, so 2 power of 5 minus 1. What will open? 2 into 2 into 2 into 2 into 2. 4, 8, 16, 32. 32 minus 1, which is 31. So your correct answer is 31. So the number of times, the total number of child process created is 31. Got it? Any kind of confusion in this person? If you guys have, you can ask. Mukesh, no. 𝗙𝗵𝗆, TP, you are getting or not? You are there? Yeah, 𝗙𝗵𝗆, very good. Now, we are moving on next question. Okay, try to solve it. One of the easiest question. I find I will take more than 30 seconds to solve this question. Now you guys can take minute. You can take 1 minute, more than 1 minute. 1 minute. Take your time and try to answer this question correctly. I think you all the guys are able to solve it correctly. Take your time. There is no issue at all. You can take 1 minute, and 1 minute is more than enough to solve this kind of question, I guess. This is your ISRO BSCC TA2021 question. It is your previous year question, I guess. Neelam, are you solving?
Yes, sir, I'm solving.
Okay.
Sir, I want to know that you will be providing notes regarding the chapters or what? Actually, we have some chapters we are not able to recall it right now.
Okay, no issue at all. I will share with you. I have some notes. You may.
Sir, can you tell me like what to refer for this?
Okay.
Which book or which chapter?
Okay. I got it. What you are trying to do. Neelam, I will share my notes in Telegram group, so you may refer from there. You may refer my notes. Okay.
Okay, sure. Thank you.
Welcome. Mukesh, what about you? One minute. Okay. Let's try to solve. I'm going to start solving. Okay. So, see what we have to do in question. Neelam and 𝗙𝗵𝗶, focus here. I will explain you each and everything in this question, so you guys will able to solve all kind of question from this topic. Okay. See, consider the following process table with the arrival time and burst time given in milliseconds. Okay. This is your arrival time, this is your first time, and this is your process time, or we can say process ID simply. Okay. So see over here. There are 4 processes. Okay. These are the times, arrival times of the processes, and these are the burst time of the processes. Okay. What they are saying if a non-primitive XJF wait a minute guys. Okay, fine. What they are saying, if non-primitive XJF shortest job first is followed the average waiting time. They are firstly what they are asking average waiting time. So see, firstly you have to recall some formulas. Firstly we have to calculate turnaround time. Okay, what is the formula of calculating turnaround time? Simply what you have to do, completion time minus arrival time. This is the simple formula of calculating turnaround time. Completion time of the process and arrival time of the process. We are talking about same process. Okay. After that, we have to calculate waiting time. How we can calculate waiting time? Just very easy. You just have to turnaround time minus burst time. For calculating the waiting time, you just have to subtract burst time from the turnaround time. That's it. These two formula you have to remember for solving this question. Okay. Now see how I am going to solve this question. Just focus. Okay. Focus over here. First, we will draw the Gantt chart, which is at most important to solve such kind of question. Okay. So here what I'm doing, I'm just drawing Gantt chart. Okay. See over here. Which algorithm we are applying? We are applying shortest job first. What it is mean? The the burst time of the process is smallest will execute or we will provide the CPU first for that particular process. So see, first we have to check that particular process is alive in the lady queue or not. So at time 0, only there is only one process which is alive in a lady queue. Okay, so there is only one process, so there is any kind of criteria of priority? No sir, I am alone, I can do whatever I want. There is no criteria of priority. Why? Just because I am alone right now in the lady queue. Okay, and second thing which you have to notice, what it is, I am using non-primitive. We can't take the CPU forcefully from the of the process in non-primitive mode. If we are applying shortage of first algo in primitive mode, that time we can take the CPU from the process forcefully. But whenever we are using non-primitive algorithm, we can't do that. Okay, so if process 1 P1 will take CPU first, so it will run till it finish their execution completely. So it will simply run at or what we can say till 7 time duration. Okay, so P1 alive 0 पे, P1 is alive in lady queue at 0 and it will completed at 7. Okay, it will completed at 7 just because of non-primitive mode. Once it will get the CPU, it will complete their execution. Before it, we can't take CPU from it. Okay, this is what I'm saying. Now you can see there are three processes P2, P3, and P4 already alive in lady queue. Okay, P2, P3, and P4. These three processes arrived in the lady queue. 2 arrived at 1 time, 3 arrived at 2 time, 4 arrived at 3 time. Okay, so now we are at 7 time. At time 7. So these three processes already in lady queue. Okay, got it? Now the second point comes into the picture. Now we have to check priority. The smallest one will get CPU first. After that, the second smallest, third smallest, and so on. So now see 4, 9, 6. Which is smallest? 4. 4 process ID P2. Now P2 will take CPU and will start their execution. So it will finish their execution at 4 plus 7. 7 plus 4, it is 11. So it will stop, or we can say finish their execution at 11 time slice. Okay, now what will happen? See again 9, 5. Which is smallest? 5. Process P4. So P4 will take CPU and start their execution. It will finish their execution at 11 plus 5. We have to add simply. Okay, so it is 16. Okay, so at 16, P4 will finish their execution. Now there is only one process remaining, which is P3. Okay, so from 16 onwards and plus 9. Which is 25, I guess. Okay, so it will finish their education at 25. Okay, this is our Gantt chart. Now you can calculate each and everything from this Gantt chart. See, firstly, process IDs. Okay, P1, P2, P3, P4. Completion time of this process. P1 completed at time 7. Okay. P2 completed at time 11. P3 completed at time 25. P4 completed at time 16. Okay, sir, I got it. Now what we have to do? Arrival time. Zero arrived at 0. Okay, we know that. Okay, fine, sir. Okay, we have to take it from here. Okay, arrival time 0. P2 arrived at 1, P3 arrived at 2, and P4 arrived at 4. Okay, P2 arrived at 1. Okay, P2 arrived at 1, P3 arrived at 2, and P4 3. 2 and 3. Okay, now we have completion time, arrival time. We have to calculate the turnaround time. Simple. What we have to do? We have to subtract arrival time from the completion time. Completion time of V1 7 minus arrival time of V1 0. So simply minus 0. So it is 7. 11 minus 1, which is 10. 25 minus 2, which is 23. 16 minus 3, which is 13. Okay, obviously, sir. So this is your turnaround time. Okay, I think you guys are able to understand what I am doing over here. Okay, so I am writing here TAT 7, 10, 23 and 13. Now what we have to calculate? We have to simply calculate a waiting time. What we will do to calculate waiting time? Turnaround time minus burst time. Now we have to go over here and we have to write this burst time. Okay, 7 7495 7495 7495. Okay, 7495 BTL. Okay, BT stands for burst time. Okay, this is your turnaround time. Okay, so now what we are doing? We are minus 7, we are minus 4, we are minus 9, or we are minus 5 for calculating waiting time. Okay, 7 minus 7 0. We are minus burst time from the turnaround time for calculating waiting time. Okay, this is our turnaround time, this is our burst time, and we are subtracting it. Okay, 7 minus 7 0. 10 minus 4 6. 23 minus 9, I guess it's 3. 20, 6, 14. Okay, this is 14. Okay, and 13 minus 5, which is 8. Obviously, so now 18 plus 14 plus 8 plus 0, because we have to calculate average waiting time. Average, what we do? Average number of terms but a total number of terms. Okay, so average waiting time, total number of process, each process, and total number of process. There are 4 process. Just do it. Okay, so this is 14 plus 6 20 plus 8 28 divided by 4, which is 14 by 2, which is 7. Okay, I hope so 7 is your correct answer. Let's see there is option available or not. Oh, option number A is your correct answer. If we are solving it through the non-primitive mode, if we will use primitive mode, then maybe answer may differ. Okay, there is one student dharma for you all. You have to solve this question by using HJF primitive mode. Okay, primitive mode. Okay, got it. Primitive mode means that you can, what you can do, you can simply take the CPU from the currently learning process before is completed their execution. This is the simple difference between preemptive mode and non-preemptive mode. In non-preemptive mode, you can't take the CPU forcefully, but in preemptive mode, you can take it. Okay. Also, you guys got it. Neelam, 𝗙𝗵𝗃, Mukesh, is it clear to you all or not? If you have any doubt, you can ask. Mukesh, 6.25 is the answer. हाँ नीलम से.
Sir, clear.
Yeah, say Neelam. Okay, 𝗙𝗵𝗃. What about you, Mukesh? Got it? Where you are doing mistake or what you are doing? Do you want to explain how you are getting 6.25? Are you using non-primitive mode? Mukesh Kumar.
सॉरी सर, थोड़ा नेटवर्क इश्यू हो रहा है.
No, it's okay. Tell me, you are using non-primitive mode or primitive mode? If you are comfortable in Hindi, you can talk. No issue at all.
यस सर, मैंने मतलब यूज तो मैंने वही नॉन प्रिमिटिव ही किया था, बट अराइवल टाइम मैंने नहीं देखा. शॉर्टेज जो फर्स्ट में केवल शॉर्टेस्ट बर्स्ट टाइम के अनुसार उसको जो गैंट चार्ट बना के कैलकुलेट कर दिया.
Okay, no issue. Now you got it?
यस.
Okay, बहुत अच्छे. No issue at all. You can do mistakes happens. There is no issue at all in this case. Okay. Okay, this is completed. Okay, this one. Okay, this one we are going to solve. Okay, try to solve it. It is easiest question. That's why I am solving. Because I'm looking easiest question which we can solve within few minutes, and after that the remaining question will take some time, so we will solve it. After solving those questions which will take less time. Comment fast. You have only 30 seconds. This is not more than 30 seconds. 30 seconds is enough for this question, I guess. Do it fast, guys. It is from and notation. Very easiest question. Okay. You guys can comment your answer into the chat box. I'm solving it. Okay. So what is question is saying? The time of execution of algorithm A is 10 to the power 3. Okay. And that for B is and for B it is 1000 n square. Okay. Second, where n is the size of any input. Okay, size of input array. Okay, what they are saying, where n is the size of input array. There is a array which we are taking input. The size of that n, size of that array denoted by n. Okay, so which of the following is true? What they are saying, algorithm A is always faster than B. Option 1 इसे अभी अपन लगते हैं. Algorithm B is faster than input size n, greater than 100. Okay. Algorithm A is faster for input size n greater than 100, and algorithm B is always faster than algorithm A. Okay. Anybody answered? Just wait a minute. D option. Okay. Let's see. Okay. So algorithm A is 10 to the power q, and that for B is 10 to the power. Okay. See. 10 to the power n cube and B बराबर 1000 n square. See, for some of the values, for some of the smallest value, maybe B is greater than A. Like you can take, see, 1, we are taking n equal 1. Put in A and B. See, 10, 1 का cube equal to 8 into 1 बराबर 10. A 1000, 1 square बराबर 1000 into 1 बराबर 1000. What we can say? A is less than B. True? Yes, sir. This is true. We are taking n बराबर 1. So what we are getting? We are getting B is greater than A. Absolutely right. You are right. Yeah. If what if, sir? What if we are taking A बराबर n बराबर 3, then what will happen, sir? Again, sir, we will greater than A. Obviously, sir, you can put. Okay, let's see. 10, 3 cube. It is 27 into 10, which is 270, and it is 1000 into 3 square, which is 9. Okay, sir, 9000. Yeah, sir. But what if I will talk about 10 to the power 10? What if I will talk about 10,000? Now you can put what you will get. A is greater than B. Now you will get why this thing happened. See, this is cubic function and this is quadratic function. Okay, and in algorithm we just ignore the constants. We are not bothered about constant. We are bothered about, we always think about growth of the function. Okay, we are not bothered about this concept. We can neglect it. We are not going to take care of this concept constant. We will take care of this function, only functions. Now you can say what is greater, and the growth of this function is higher. You will definitely say n cube is a cubic, so the growth of cubic function is always more than growth of square function. Okay, I think this is very important point which I am discussing with you all. Okay, I have given example to you. If you don't believe on me, you don't have trust on me, now you can put n equal to 10,000. Okay, then you can check, you will find A is greater than B. Definitely you will find, you can verify it right now, right here. Okay, so what will be the answer of this question? Now you guys are able to solve it very easily. Okay, so algorithm A is always faster than algorithm B. Algorithm B is faster for input size and greater than 100. V is faster for input size. No, algorithm A is faster for input size and greater than. Okay, always this is long. Why? Because if we talk about n बराबर 1, no sir, V is faster. n बराबर 2, n बराबर 3, n बराबर 4. But maybe there is some threshold value. From there, the value of A always be greater or faster than input size of V. Okay. So for that, we can say option C is correct. Got it or not? Mukesh, Neelam, you guys have any
Yes,
doubt?
sir. No, sir.
ओके, बहुत अच्छे. ऋषिकेश, मुकेश, you guys got it or not? Kindly acknowledge so that I will move further. I'm looking to easiest questions so that I can solve those questions fastly. This is also one of the easiest question. Before it, I'm taking more questions. I can. Okay, now try to solve it. Solve it, Neelam, Mukesh. You are able to solve. Mukesh. Solve it, ladke. Try to solve it. Option C is the correct answer. Okay, Mukesh. Neelam, try to solve it. Okay, see. What they are asking in this question, the number of statutorily different possible binary tree with AND nodes. We are talking about node. Okay, we are not talking about keys.
Sir, option A.
Okay, okay, Neelam. देखते हैं. Okay, you can verify. Okay, okay. So what we are doing over here? Node, number of nodes. Okay, structure possible with AND nodes. Okay, so there is one simple formula which is 2n cn बटे में n plus 1. It is also known as Catalan number. Catalan number. Most important formula. This formula also used for calculating stack permutation. Stack permutation. Number of binary tree or number of binary search tree. For calculating these with AND nodes, you can use same formula with AND nodes. Okay, you guys have to use this formula for calculating these things. Okay, so now at place of n you can put 4 and you can easily calculate 2 into 4. See, 4 plus 1, which is 8c4 and divided 5. So now what you have to do, I think you guys already know what is the formula of NCR. Okay, this is generally your mathematics. Okay, तो 8 factorial बटे में 4 factorial n factorial बटे में r factorial into में n minus r factorial. ठीक है, this is the formula. I have already written over here. You can check it out. Okay, तो n 4 factorial into में 5 factorial. This thing I'm taking up. Okay, okay, ठीक है, this thing will come over here. Now you have to solve it simply. 8, 7, 6, 5, 4 factorial बटे में 4, 3, 2, 1 into में 4 factorial into में 5. 4 cancel out, 5 cancel out, 3 2, 4 8, 2, which is 2 into 7, which is 14. There are 14 structures available with AND nodes. Okay, with 4 nodes. Okay, so A for Agra. 14 is your correct answer. Very good, Neelam. What about you boys? मुकेश, ऋषिकेश, कहाँ पे हो लड़के तुम लोग? Okay, now we are moving on next question. Okay, this is your last question of the class, of today's class. We will continue from tomorrow. Wait a minute. Okay, kindly solve it. It is very easy question. A sorting technique is called stable if okay नीलम, good, बहुत अच्छे. Okay, solve it. It is very easiest question, I will say. Okay, I am solving it. Just see what is a sorting technique is called stable if. Okay, if it takes order of n log n time, it uses divide and conquer technique. Relative order of occurrence of non-distinct elements is maintained. Obviously, option C is correct. Why option C is correct? See, this is I'm taking an example over here. Just see, if a alley is given to you, which is 1, 2, 4, 2, 3, 4, 3. Okay, this is the alley given to you, and after the sorting, A 0. Okay, after the sorting, what will be your LA? 0, 1, 0, 1, 2, 4. Sorry, wait a minute. It will be like 0, 1, 2, again 2, 3, again 3, 4, again 4. So what I am saying here, the occurrence, the relative order of occurrence of non-distinct element is maintained. What it is mean? It is mean simply is that the occurrence of first 2, this will come here and this will come here. First 3, this will come here. Second 3, this will come here. First 4 will come at first position and second 4 will come at second position. This order will be maintained. This is the rule on the basis of, we can say, our technique is stable. Okay, so sorting techniques is called stable when it maintain, or what we can say, relative order of occurrence of non-distinct element is maintained. This is what they are saying in this option. So the option C is your correct answer. Okay, got it, you guys? Neelam, Mukesh, got it or not? Okay, this is our last question of the class. This is okay. We will cover this question tomorrow. It is very easy, I guess. Okay, we can solve it. First one, try to solve it. You have 35 seconds for this question. Mukesh, Neelam, try to solve it. Okay, I am solving with you all. See, a binary search tree. What is binary search tree? What is the definition of binary search tree? If loot, the value of left side, or what we can say left subtree, is always smaller than loot, and the values of right subtree are always greater than loot. This is the normal definition of binary search tree. Smallest value always in the left side, or largest value from the loot always in the right side. Okay, so see over here what will happen. What is question, what is given in question? See, a binary search tree is used to locate the number 43. Okay, which one of the following flow sequence is not possible? Okay, not possible out of given 4 flow sequence. See, we have to simply compare this element with this element. Okay, 63 is greater than 43. Okay, 63 is greater than 43. So where 43 will come? It will come left side. Okay, 43. So are the element of this is 63. All the remaining element are smaller than 63. these all the element are smaller than 61 is as or not as. All the given element are smaller than 61. Okay, now what we have to do? Again we have to check. What we have to check, sir? Now you have to check 52 is greater than or smaller than 43. 52 is greater than 43, or so what we will say, 43 will come into the left subtree of 52. So all the remaining element after 52 all smaller than 52. Yeah, so these elements are smaller. Now again we have to compare 41, 43. 43 is bigger but 41 is smaller. It will come right in the right subtree. So what we can say, all the element where we are now, 52 we have compared with 50 to 41. Already we have compared with. Okay, so now we are going to right side. Okay, let's see. We have to simply check the flow sequence. Okay, 61, 52, 41. Okay, now greater than. Okay, it will come this side. 41, 17 is smallest. Okay, we have need all the values of after 41 will be larger than 41, but here 17 is smaller than 41. Okay, now come on the second option. We are trying to verify second one. First maybe your answer. Okay, keep this thing in your mind. Now verify it. 43 and 10. 10 is smaller than 43. It will come right side. Okay, in what we can say, into the right subtree. After 10 all the values are greater than, must be greater than 10. All the values are greater than 10. Now 65 compare with 43. 65 are greater than 43. So 43 all the values after 65 must be smaller than 65. Okay, so these values are smaller than 65. Okay, now what will happen? 31 compare with 43. 43 is bigger, 31 is smaller. Okay, so all the values are bigger than 31. Okay, so all the values are greater than. Okay, now 48 is smaller than, greater than 43. Okay, so 48 greater than 43. So all the values, this will come into left subtree. So all the values are smaller, must be smaller after 48. So 37 or 43 are smaller than 48. Now 37 compared with 43. 43 are bigger and 37 are smaller. So all the values after 37 must be greater than 37, because this 43 will come right hand side. Okay, this is smaller, and now we are getting 43. So yeah, this flow sequence is absolutely valid. Okay, so based on this, what we can say, this is valid, you will try this one, this will also valid, you will try this one, this will also valid. So option A is your correct answer, which is not valid just because of this 17. Okay, got it or not? Got it, Mahesh? Mukesh, sorry. Not Mahesh, it's Mukesh. Okay. You can verify last of two options, Mukesh, if you want. Okay. Let's see if there is any. I think three or four question still remaining. Okay. We are solving. This is our last question of today's class. Okay. This is our last. Remaining we will continue from tomorrow onwards. Keep it 10 modulo con. This is the correct. This is your correct x function. x बराबर order of a x minus order of a plus 1 modulo 10. Okay, Mukesh, try to solve it. I think now you are able to solve it. I have already explained similar type of question few minutes ago. Okay, try to solve it. Okay, no worries, Mukesh. I am solving with you. Try to solve with me. Okay. Okay. So this is the string given to you. Okay. Now what we have to do? This is our as function, and the size of as table is again 10. So we have to make this as table. The size of this as table is 10. We are starting counting from the 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. This is fine. Okay. No worries. This is our last question. After this, we will continue from tomorrow's class. Okay. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, got it. Let's see. Okay, the order. You know what is the meaning of order now? The position at which they are located. Simple. Order of a 1. So what we can say? 1 plus 1 always cancel out. So we can simply say as x बराबर order of x modulo 10. This is what we can simplify our as function. Okay. So now it is very easy. The position of k is maybe 11, right? A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. Okay, this is your entire position of your each and every alphabet. You can simply see it from here. Okay, so 4, 4, 8, 9, 10, 11, 11. Okay, so the position of k is 11. Now you can see 11 modulo 10, which is 1. So your k will come at first position. Now r values are, it is the position of r 4, 4, 8, 12, 12, 16, 17, 18, 18 modulo 10, which is 8. So r will come at position 8. Okay. Again p can 18, 17, 16, 16 modulo 10, which is 6. P will come at position 6. C is 3 modulo 10, which is 3. C will come at position 3. S 19 modulo 10, which is 9. S will come over here. M N K 11, 12. K L M N 11, 12, 13, 14. N बोले तो 14 modulo 10, which is 4. It will come at position 4. What will come at position 4? N. Okay. Now Y x by z 25 modulo 10 5. Y will come at position 5 by. Okay. Now t 4 4 8 9 10 11 12 13 14 15 16 17 18 19 20 20 modulo 10 which is 0. T will come over here at position 0. J I J 4 4 8 9 10 10 modulo 10 again 0. First, second, third, because this is collision. And what probing we are using linear probing. In linear probing we increase by 1 until we get a empty slot. Okay, increased by 1 again. Now we get a empty slot. Now we can put our alphabet T J. So here we will put J. Okay. M K11 L 13 sorry 12 or M 13 modulo 10 3. It will come at position 3 already occupied. Now what will we say? Increase by 1. So here M will come out. Okay, this is your entire hash table. Okay, so what they are asking in question: if linear probing is used to resolve collision, then the following insertion causes collision by not occurring. What is occurring the collision? 13 M is occurring, right? Okay, so C will be your right answer. Got it?